everyone, today we're looking at finding the recursive formula for these two sequences. Let us begin with the arithmetic sequence. So the first thing we can notice here is that we're adding 3 from 4 to 7 and then another 3 from 7 to 10. So technically our common difference is always 3. Or in other words, to find the value of the current term, we have to add 3 to the previous term's value. So for example, if the value of our current term is 7 and the term number is 2, then if I subtract 1 from the term number, I'll go back 1 place to the term beside it, which has a value of 4, and then I add 3 to that, I will be ending up with 7 again. Now let's verify this formula with another example. Let's say that I want to find the value of the fourth term in this sequence. If I subtract 1 from 4, then I'm left with the value of the third term, right? And since I already know the value of the third term, which was 10, I can add our common difference to that, which is 3, and then we're left with 13, which indeed is the fourth term's value in the sequence. Now for the geometric sequence, it is pretty much the same idea. We're taking the value of the previous term and we're multiplying it by, this time, the common ratio. The common ratio being the multiplier between each of the terms. So in this case, that is 4, right? 4 over 1 if we want to say that as the ratio. So let's verify this one with an example 2. A of 4 minus 1 means that we're finding the value of the third term instead, because 4 minus 1 equals 3, and A of 3 is the value of the third term. So the third term in the sequence is 96. If I multiply that by 4, which is our common ratio, I'm left with 384, which is the value of the fourth term. And there you have it, finding the recursive formula for both types of sequences.